Hello everybody, this is Mr. Basil and let's get to it. So in these video notes I'm going to be covering just more examples of how to do different kinds of BCA tables, and I'm going to be giving you some hints and tricks along the way. So start by copying down, actually no, you should have a handout like this. If you don't have one, you just got to copy it down, in which case that's a lot of work, but you should have a handout like this that you can just kind of work off of, and then you can just tape or glue this into your notes for reference in the future. So for this, well, let's just dive in and see what we got. So it says how many moles of hydrogen gas will be produced if 2.5 moles of calcium hydride react according to this equation. So there's a few things we can do before even really writing anything down for this problem. We want to divide this BCA table in half, products versus reactants. And before we do anything, we're just going to put in zeros here because you're never going to have any products. So always start with zeros for products. And then let's see what information it gives us. It gives us 2.5 moles of calcium hydride. That's this guy right here. So 2.5 moles of calcium hydride, I'm going to put that right here. 2.5 moles is what I have. And we're trying to find moles of hydrogen gas in the end. Okay, so I'm just going to circle that and put a question mark there. Now, it does not give us any information about H2, so here's another note. If information about a reactant is missing, so in this case water, we're going to assume that we have a lot of it. We have a lot of it and we're not going to worry about running out of it because we don't know any information about it, so we're going to hope that that does not limit our reaction. If information about a reactant is missing, assume it has a lot, aka is excess, which we're going to shorthand to just say XS. Okay, so again, I'm going to just write in excess or XS because we're not going to run out of water. That's what we're going to assume. We're not going to run out of that. The CaH2 is going to be our limiting reactant then, because we don't have to worry about how that's going to run out. Alright, so now we have to figure out how we're going to do our change row. So the way we do that is we take our information and we divide it by the coefficient. So in this case 2.5 divided by 1, that equals 2.5. Okay, so now we're going to take that, zoom in just a little bit here, we're going to take 2.5, we're going to multiply it by each of the coefficients here. Multiply, 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 multiply. And that's what goes in our change row. So I've got 2.5 here. 2.5 times 2, that gets me 5. 2.5 times 1, that's 2.5. And then 2.5 times 2, that gets me 5. Now, the one thing I'm not writing here is moles. 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 We can only use moles in a BCA table, which is good. Alright, and then we're going to lose reactants and gain products. That's always the case. Always, always, always lose reactants, gain products. And then we just have to do our little addition or subtraction here. So 0. We don't know how much is going to be left. So we'll just say some more excess. Excess, I guess. Now, it depends upon how much we started with, which it doesn't tell us. And then over here, this is easy. 2.5 and 5, because 0 plus 5, that gets me 5. And then the 0 plus 2.5 gets me 2.5. Now, we figured out what everything is, but we need to figure out, what is the question asking for? Remember, it was moles of hydrogen gas. So, that's this one. H2, that corresponds with everything in this column. Everything in this column is for H2. Everything in this column is for CaOH2, calcium hydroxide. So this right here tells me that after, this is the after row, I have 5 moles of H2. And that would be my answer. So there we go. Let's do a few more examples because it's not always going to be this straightforward. This was an example showing you, hey, what do we do if we have like something like this? We're going to use excess. And some of these we're going to say, well, what if it asks for something else, like not a product? Or what if it gives me a product and asks me for a reactant? So those are all things that you're going to have to come across. All right, so this one says how many moles of oxygen gas, moles of oxygen gas, that's what we're going to try to find, are needed in order to produce 5.5 moles of carbon dioxide. I recommend you highlighting your paper like this too. Helps you organize yourself. All right, now before we fill in anything, there's two things you should always do. Either write down your BCA table or at least divide it in half, so that way you separate your products from reactants. Products always start with 0, always, always. And in this case, it gives me products. So it says to produce 5.5 moles of carbon dioxide. So what that means is in the end, after this is all done, I'm going to have 5.5 moles. Okay, now that might be confusing. You might be thinking, well, shouldn't 5.5 go here? Nope, does not. Because before we make any s'mores, right, we do not have any s'mores. This is like saying, hey, if you wanted to make 108 s'mores, how many pieces of chocolate do you need? So in the same case, we do not have any CO2 before this chemical reaction takes place. So this one has to be a 0. So this one we're going to kind of have to work backwards for just a little bit, but the process is still the same. So I guess we could start here, and we know that this has to be plus 5.5, because 0 plus 5.5 gets me 5.5. Now, we're going to do the same thing as before. We're going to take this and divide it by 12, divide it by its coefficient. So 5.5 divided by 12, that gets me, check my notes here, 0.4583. It's not a very nice number, but that happens a lot. So this is the number we're going to use to multiply by each of the coefficients. And when we do that, you're going to have to use your calculator for that one. We end up with, so this one for water, for H2O, we end up with 2.7498. This will be an add because it's a product. And then this number, the 0.4583 times 15, we're going to get 6.7845. And this will be a subtract because it's reactant. Same number times 2. We get 0.9166. It'll also be a subtract because it's reactant. Now at this point you might be thinking, well, now what? There's like a lot of things missing over here. I guess we could jump over here and say, well, this would be 2.7498. But remember, the previous problem what we decided is if we don't know something about this, let's just say we have a lot of it and not worry about it. And so let's just call both of these excess. Okay. We don't know which of these will be in excess. We'd have to be given that information in order to know that. And who knows how much of this stuff we'd have left over. Let's just call it excess again of both of them. But what we know, and this might be interesting, what we know is that we need at least this much O2 and this much C6H6 in order to, make 5.5 moles. And the question says, how many moles of oxygen gas are needed? Well, this right here tells me how much is needed. So I'm going to circle this and then just bring it off to the side and say we need 6.7845 moles of O2. Right, we need that. I wouldn't say we need a negative amount, right? Because that wouldn't make sense. We don't need a negative amount. The negative just shows that I'm decreasing my amount of oxygen because that's getting used up. And it's saying, I need that much O2. All right, let's keep plugging along and let's do this last one here. So it says lead will react with hydrochloric acid, blah, 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 blah. How many moles of HCl, hydrochloric acid, are needed to completely react with 4 moles of lead? So here's what I'm going to do. I'm going to give you the equation for this. So it's Pb plus 2HCl. I don't want you to try to do this one on your own. PbCl H2 plus H2. Pause it. See if you can do this one on your own. Really, try it. See if you can. I'm going to go over the example here just very quickly here in just a moment, but I bet you know enough at this point to at least kind of stumble through at least the first couple steps if you can. At least try to do the first steps, like where should the dashed line go? Where should the zeros go? See if you can at least do that much and see if you can do more. All right. So I'm just going to go through this quickly now. Hopefully you at least attempted this, but you should have put your dashed line at the arrow, and you start with zero products always. It says we start with 4 moles of lead, so I'm going to put my 4 there. We do not know how much HCl it needs, so I'm just going to put excess there. Now, the first thing we do is we take our given, divide it by its coefficient, in which case it's 4 divided by 1, which equals 4. We're going to take that, multiply it by each of the coefficients. This one's nice. This one's, we can do it without a calculator mostly. And so we get times. 4 times 1 is 4 for lead. 4 times 2 for HCl is 8. And then we just get 4 and 4 over here. Now we have to add our products, subtract our reactants, right? Because the reactants get used up. Products are produced or made. And in the end, we end up with 4 and 4. 0 lead, because that's our limiting reactant that gets used up. And I don't know how much HCl is left. I don't know. We weren't told how much we had to start with, so we're going to hope that we have some excess. And then we go back to the question, how many moles of HCl, hydrochloric acid, are needed to react? Well, 8. We need 8, right? Right here, it's just like the previous problem, or the last one. We need 8 moles of HCl. There we go. All right, that was it. That was a lot of examples, a lot of things, but that's what you got, and good luck on your practice. See you next time.